All right, last part of projectiles is when we're looking at angled projectiles. So now this is the most complex one because we have to find a lot of stuff at the start. With vertical projectiles, we could just ignore everything in X. We only worked with Y. If we looked at horizontal projectiles, we knew some of the starting stuff for the Y was zero, especially the velocity. Now we've got to find a bunch of stuff at the start. But when you see angled projectiles, I want you to think of these three steps. One, find X and Y velocity. I'm going to abbreviate velocity velo. Two, find time. Even if the problem doesn't ask you for it, find the time first. Okay. And then three, solve the question. Okay, solve what it's asking for. That's the difficult part about these. In order to find anything we ask you, you're going to need time, and you just need to recognize to do that. So let's draw the triangle first. Okay. So a shot put leaves the athlete's hand at a 55-degree angle. Okay. So we know that angle is 55 degrees, and we know the total velocity is 3.5 meters a second. Remember, when you see words like total, complete, all, things that are combined, that's telling you that it's the hypotenuse of the triangle. So now we've got to solve for a y velocity that's this way, and we have to solve for an x velocity that's this way. And this is why we gave you a quiz on this, because if you can't solve this simple triangle to get the other sides, the other components, it's going to be real tough to solve this problem. So let's solve for the x first. Okay, it's the adjacent part of the triangle. So when you solve for this, it's going to be cosine of 55 equals the adjacent angle, which is x, question mark, over the hypotenuse is 3.5. So our velocity in the x to start is 2.0 meters a second. And then let's do the same thing for the y. If we look at the y, do you see how it's the opposite of the angle? So it's the sine of 55 equals question mark over 3.5. And if you solve for that, the velocity in the y to start is 2.87 meters a second. And round your trig answers to 2 decimal points. With trigonometry, you're always going to have kind of those ugly decimals. So anytime you use a trig function, just round it to 2 decimal places. So we have a y starting velocity and an x starting velocity. There's step one. Now let's list what we know. We're looking for how high does the shot put reach. So that's its highest point. Think back to what we did in vertical projectiles. We know the velocity final there is 0 because it's got to go up and stop. And then our acceleration is negative 9.8 meters a second squared. And then remember for x, same thing. Gravity isn't pulling in the x direction. Gravity doesn't pull horizontally. Gravity only pulls vertically. So we have our acceleration in the x is 0 meters a second. So when we look at this, what do we know 3 things about? We know 3 things about the y, so that's where we start. Okay. When we look at this, we've got to find time first. But Mr. Peterson, it doesn't ask you about time. Doesn't matter. You just got to solve for the time first. So we have a velocity final. Okay. We have a velocity initial. Okay. And we have an acceleration. So we want to use this formula. Neither of those are going to help us because we have to solve for time. And here, when we look at this one, we don't know how high it's going. So it's not going to help us either of those. So we got to use that top one. So our velocity final is 0 equals negative 9.8 t, okay, plus 2.87 meters per second. Again, that's our starting y velocity, bring the negative 2.87 over to the other side, negative 9.8 t, and it's 0.29 seconds to the top. Okay? Now, read these questions carefully. If a question asks you how long is it in the air, it'd be 0.6 seconds, right? 0.29 times 3, or times 2, I'm sorry, because it's got to go up and down. But we've looked at this projectile. It's going to go up, stop, and come back down. We figured this is 0.29 seconds, so that means the other half of the arc has to be 0.29 seconds. So now we're looking for a y distance, right? How high does it go? We're looking for a y, and it only takes this much time, so we don't have to double it to find the high point because it takes 0.29 seconds to reach the high point. You can use either formula. I'll set them both up now. So the change in y, I don't want circle y, I want delta y. Okay, so the change in y equals 1/2, excuse me, times negative 9.8 times 0.29 squared. Plus, remember, V0 is not 0 like it was in the other one, so we have to include this term. V0 is 2.87 positive times the time, 0.29. Don't forget your parentheses, and if you plug that into your calculator, you're going to get a change in y of 0.41 meters. You can also use the other formula. We know our final velocity at the top is 0 squared equals 2.87 squared. Oop, erase that. Stupid autocorrect. Happens in your text messages. It happens in your physics homework as well. 2.87 squared plus 2 times negative 9.8 times delta t. So 0 equals negative 8.21 plus 19.6 t. Don't forget, in the other formula, it's half of 9.8. In this formula, it's doubling it. So just be careful which formula you're looking at. But 2 times negative 9.8 is 19.6. Okay. So 8.21 negative, bring it to the other side, equals negative 19.6 t. Or negative point, I'm sorry, this should all be delta y. Sorry. Delta y for those formulas. I'll go change that. Delta y. We're not solving for time, we're solving for a distance. Delta y, delta y. And if you solve for the change in y there, you're also going to get delta y. You're also going to get 0.41 meters. So the y distance is 0.41 meters. Again, you can use this formula or that formula. It'll come out the same way. Now we got to solve the other problem. Asks for how far along the ground does it travel. That's the x. And remember, x is a little bit simpler to solve for because we know that acceleration is 0. So we can use speed times time equals distance. Okay. So we know our initial x speed is 2.0 meters a second. We know how long it was in the air was 0.6 seconds, 0.29 times 2, because we need the time for it to go up and down. So we're going to get 1.16 meters in the x direction. We have some time to practice these in class. Go try the ones in your packet.